Hello, welcome to my presentation on managing machine learning project. Today we are going to explore the key steps involved in building a machine learning system, from opportunity evaluation to solution validation and production deployment. My name is Jude Correa and I'm super excited to walk you through my project today. So let's get started with the agenda. First, I'll give you an introduction to the project and talk about the opportunity evaluation. Then I'll dive into the CRISP-DM approach I used and I explain the solution validation plan. After that, we'll talk about the machine learning system design and the potential risk in production. Okay, let's jump into it. So the machine learning system I want to design is going to predict network outages in the telecom industry. It's going to be a machine learning based solution that analyzes historical data and real-time network performance to identify patterns and anomalies that could indicate an impending outage. That way, the network operators can take action before downtime even occurs, which is going to improve the reliability and efficiency of telecom network. Before we get to the nitty-gritty of the project, let's talk about the opportunity evaluation. So predicting outages before they happen can prevent a lot of headaches, both for the telecom company and for the customers. There's a ton of data available for us to work with, including the network performance data and maintenance logs, which is super exciting. And traditionally, the rules-based systems have not been able to capture complex patterns and anomalies in data, making this new approach more effective. Now let's deep dive into the CRISP-DM approach. Basically, the problem that we are trying to solve is to build a machine learning model that can accurately predict the network outages in real time. Success is going to be defined by the model's ability to accurately predict outages while minimizing the false positives. That's going to be measured by the reduction in the overall outage rates and the model's precision and recall. We are going to be looking at factors like network performance data, maintenance logs, weather data, and other features that may be indicative of the network outages. The solution validation plan is going to involve a bunch of experiments with different models and parameters to optimize accuracy and minimize false positives. We'll be splitting the historical data into training and validation sets, and then evaluating the model on a test data set to make sure it can handle new data. So we'll be analyzing historical network performance data and other relevant data to identify patterns and anomalies that indicate network outage. All right, so let's talk about the machine learning system design. We are going to be using a cloud-based system that allows for scalability and easy integration with the existing technology stack. For training, we are going to use offline learning, while online learning will enable the model to adapt to new patterns and anomalies in real time. Online predictions will be used to provide real-time alerts to the network operations team. As with any project, there are many potential risks in production that we need to be aware of. First, changes in the network infrastructure or usage patterns can impact the effectiveness of the model over time. Second, differences between the training and production environments may impact the effectiveness of the model. Lastly, latency of the model may impact its ability to provide real-time alerts in a timely manner. So let's recap what we have covered in this presentation. We are building a machine learning based solution to predict network outages in the telecom industry. The opportunity is attractive because predicting outages before they occur can enable the telecom company to take proactive measures to prevent them, leading to better customer experience and reduced downtime. We have a large amount of data available, including network performance data, maintenance logs, and other relevant information that we'll use to train the model. Success will be defined by the model's accuracy in predicting outages while minimizing false positives, and a validation plan involving iterative experiments will be used to optimize accuracy. We'll design the ML system as a cloud-based system using offline learning for training and online learning and online predictions for real-time adaptations and alerts. Finally, we have discussed some potential risk in production, including the data drift, training serving skew, and latency. Thank you. That's all for this presentation. Thank you for joining me today, and if you have any questions or comments, feel free to reach out to me via email.